Okay, so I'm going to give a non-technical talk. It's probably the only one apart from the introduction at the minute. I'm going to try and take on the role of a customer advocate. I will talk about sort of Cisco's internal customers and our market spaces, and then I'll try and give my views. I use musing because musing can mean reflections, so you'll see a bit of that. It can also mean daydreaming, so you'll see a lot of that as I go through. But just hang with me. Hopefully I can give you some food for thought, and then after me you get some food for your educated palates. So we should be good. So Cisco, like a lot of other companies, we've got these big markets. Now, I'm not a marketing person. My slides were done really quickly, not like Christian, so people won't say, "Where's your slides?" So don't read anything into this. IoT market is not smaller than our traditional market and things like that. It's just I stuck a PowerPoint. What this is trying to show is that we basically got, yet again, because this happens at Cisco quite a bit, we've got a full mesh. If you look at our traditional market, we started off, when I started at Cisco, we had this problem that there was IPX, Vines, LAT, IP, lots of protocols. We could basically switch any to any. So we started looking, well, what's common? We needed some focal point, and what we found out that was common is you had this thing called an encapsulation, and then the rest of the packet. DPI wasn't invented then, we just had to get things through. So we started looking at how we can optimize that. So we didn't look at each packet, we just said, well, how do we optimize that part? And we basically turned a routing problem into a switching problem. You go through the control plane once, you find your rewrite, you keep that in a cache, you do a cache lookup, a couple of DMAs. That's worked for a long, long time. It'll still work. I'll try and explain later when I don't think it's started. It can carry on working because of DPI and service headers and things like that, but we'll get to that. So there's one case we started doing that. We did it in software first. We then put it into hardware. So we started having, I think the SSE was our first silicon switch engine, or SSE. So we keep finding these things. It's like an hourglass. We keep diverging, converging, diverging, converging. And DPDK has taken a similar thing where they've measured things like IOGLBs, found out they sucked, tried a software thing, moved it into the hardware, and so we keep seeing that, especially in the I/O area. And a lot of this talk is mainly on I/O. Our cloud stuff, I think everybody knows what the cloud is. I think SDN still does nothing, but there's obviously different algorithms. Our embedded IoT, actually in Cisco, it's IoE, but the E is everything, and it'd take too long to enumerate all the things, so we just call it IoT for this. It's meant to be the stepping stone in some ways between traditional and cloud. You can have everything in the cloud, but we've got this idea of fog. And what fog is basically, if you're a researcher out in the field using an iPhone, you've got some growth data on trees. The only place you can get that data is back in the US in this big data farm and things like that. So you've got a lot of latency. So how can we pull compute and data down to the edge of the node, down more on the ground, so that user with his iPhone gets better service? So a lot of IoT is sensors and things like that at a lower level. I don't know who came up with fog, but there's this misconception, and I grew up in England, so there was lots of fog, and I keep thinking the cloud, when it crashes, is fog, because it's on the ground. That's not true. Fog had nothing to do with that. So we've got these three big markets. At the bottom, we've got a few. This isn't all the CPU vendors. We've got lots of boutique ones as well. These are vendors that we deal with, and we've got this constant mesh. If you take out that mesh, you look, really things separate into two lines, and I'll call these innovation boundaries, because we've found that we've had to innovate in this area quite a lot to move forward. We are not going to stop innovation above us. That's why that line is green. We in this community have got to make ourselves relevant. And that sounds like a harsh statement, but when I talk to the guys back home, we have a thing called Caltrans, which looks after the road and things like that. And I don't know anyone who's gone home, phoned Caltrans and said, I had a great ride home today. It doesn't happen. We're at that level. Get used to it, guys. It's reality. There's a lot of people above us who are running Java, Python, Go. They're the ones writing these applications. They've never heard of C. I can't hire C programmers now. I've got to train them when they come in. So they're part of our community. We've got these sensor guys who, you know, all these little things, thousands and thousands of them coming in, wanting to be aggregated, moved up to the cloud. Again, completely different market. And then DPDK really has given us a chance to innovate in the traditional way. I actually call it legacy, but Mark didn't like that, so the traditional way. So it is opening up things. We've changed a lot of our code base, but we can't keep changing our code base. The APIs have got to be relevant to the customers. And this is just a small set of customers, but if you can do a crypto API that OpenSSL can work with and libcrypto can work with, you're going to succeed. Because those guys are going to use those components anyway. They're going to put them together. And if we don't do this, you're going to get the Googles, the Facebooks, and people like that. They will go and get people. They'll write to these engines directly, so everything's going to diverge. We're going to have a much harder problem, and then we'll have to start integrating in those APIs. So you would end up with something sort of like this, where you've got not a common API, but a unified API. And a unified means that you carve off a little section for every new boutique architecture that comes along. You add that, and we have this growth. Nothing really works very well. I call this AL because we had a lot of debates inside, and you could say it's an architectural level sort of view. It could be an adaptation layer because there's got to be a lot of adaptation in here. You could call it an abstraction layer. I don't care about the name, but the type of things I'm needing to accelerate at the minute are networks, crypto, disk, those sort of things. You get the VMs out in the cloud, they all use those things. They can all be handled by DPDK and other things at this level. We saw at the San Francisco Summit, there's people doing just petabytes of data through DPDK acceleration and things like that. So it's coming. It's not just about a network type thing anymore. Then we've got these whole containers and all that sort of stuff. So we've really got to start looking at how do we support the innovation from above, and then below, how do we allow the Intels, the Caviums, the ARMs to innovate? Because we can't stop that. There's a lot of hardware acceleration innovation going on. Intel have got their thing with the FPGA and stuff like that, where we're tending to look at Open vSwitch and then how can we patch around that by doing FPGAs. That's the most pragmatic way forward. But I'd also like people to look and say, is that the way we should be going? And I'm not asking people to rewrite everything because we'll just end up putting more bugs in later. The nice shiny toys won't last. We've got to be able to migrate this, take it forward, and stay relevant. And remember Caltrans, because if we do stuff that isn't usable by the communities, Ericsson probably have a similar problem to us at this level. It's just not going to get used, and again, we end up diversion. This little wrapper facade. So we did an ETH tool thing that got talked about earlier. This is something that is only there to support a legacy or traditional app. I don't want it in main DPDK. It shouldn't be the design point. It's a band-aid to help this legacy stuff move forward. Yeah, it was interesting the debates we went on with Thomas about, you know, how do you get this in? Is it core? It ended up in the applications directory. Then we started writing makefiles so that it could work outside. And it really was the first thing that came along that really shouldn't be core to the actual DPDK, but is needed to support certain environments. And I heard another couple of things that people have discussed today that would fall in exactly the same thing, where you don't want to get all the extra entropy of having to contain that within DPDK, but it's a necessary evil. The containers in VM, there's a ton of stuff there. Entropy in VMs across all these different vendors, stuff. You know, I don't really want to go into that level because that, by necessity, would get to be technical. And this may look the same, but it's actually not. It's that hourglass thing again. We've got to come to a common API. We can't keep adding and adding. And more than an API, I want an interface. Now, it's a subtle difference, but to me, an API plus a language binding is an interface. So we've got to look at how we do support these other languages that are out there and allow them to get hold of some of the power that we've actually got across this sort of I/O abstraction layer. So that there really is an hourglass there thing. I think we've looked, the hourglass to me shows two things. It shows a waste. It also shows that there's a time factor. So at the top, you're discovering, you've come and learned, you've got that opportunity there at the waist to do something, then it starts diverging again and you'll never control it again. So I believe that we're about at the right level to start looking at some of this. So on that, I'd like to give some goals. So as I said earlier, we've got to decouple the innovation boundary. We can't stop people working above. We don't want to stop the processors working below. You know, we really need to enable both, and I think we can do that with the appropriate APIs. This is another good management thing. We've got to increase the velocity, reduce the effort, improve the quality. It sounds fairly motherhood and apple pie, but you know, lots of routers. I read a report the other day that people will start attacking routers a lot more. You had the sinful thing with Cisco, which wasn't actually a security thing at all. It was an administration thing. But then you start reading that 83% of the routers that have been attacked are ARM because of the instruction set and things like that. So how can we, in this community, start looking at security and things like that from a different perspective? We talk about inline security and crypto and things like that, but there's other things that we need to start doing. We need to start hardening. So, you know, we need those sort of things, and that's going to take a lot of innovation. I think the bottom line, you can read the other words, the bottom one said it all, performance portability. What does that mean? It means I don't want to take ODP and run DPDK under it. I don't want to do it the other way round. It's just, that's not the way to do it. You know, we've got to start getting together, leveraging the best parts, and I think under this API we can actually do that, and I should get a performance guarantee. We're talking about it earlier about going from a vector mode driver to another one, but this is going to get worse as you start going across the spectrum. In some places you're going to have an ARM as a coprocessor, a Cavium or something like that. In other places that's a first-class citizen in this NFV. It's just doing a reduced set of function. If you look in the fog layer, it's maybe closer to the edge than other places, but you know, we've got to have that. And there's some more requirements when I get into the requirements that we'll need. So AR for abstraction, you fill in whatever, it's not my initials though. Common and open. Open coming from someone like Cisco is a pretty major word. We do mean it. We do want to contribute. We had a pretty rough start. I hacked a patch once, and someone called Thomas said, yeah, a couple of guys from Cisco. Never heard of them before. They're the ones, just forget those guys. But you know, we didn't know Thomas, and he's a great guy. He's just got to not get arrested for doing work outside of work time in France, and do stuff like that. I actually got told that he checked in the 2.1 code on vacation. That's a capital offense over there. So, you know, as Roger said, hats off to him. So yeah, it's got to be common. We've got to find a way of moving these things forward. Different vendor IOs, I think I've gone over that. Leverage hardware offload if available. Again, that sounds obvious. Yes, we will do that. But remember, the policies are going to be different now. The policies are going to come from the cloud, and it's going to be based on dollars. Because if Intel make a function that I can use in my applications, let's take Cashku OS, then I can do that, and I pay Intel a bit more money for doing that. Now, if I can pass that on to my vendor, and he can make additional money by saying, hey, I'll give you 50% of the cash if you pay me $50,000, you're paying me $1. Well, you may get some cycles elsewhere. So again, you're getting facilities in these boxes now that you can pass on, and service providers can make money based on those. Again, what the policies are and things like that is going to be a lot harder. If we have our own dedicated box, we can go in, we can tune our application. But as Stephen, Roger, lots of people have said, you guys have said, we're running on these VMs, we have no control. Somebody else has got it, you may be out on AWS, yet you don't have those controls. So I think you've got to set up some policies and things like that based on that. And that means you've got to have capabilities, discovery, and other things like that. Classification, packet steering, we've already heard a couple of things. That's what people are starting to look. What takes the CPU cycles? How do we move flexible packet classifiers in? There's a lot of work around vSwitch on this area, and you're getting good results. Time management, event management. If you go to ODP, you're not in there 10 seconds before you find out about event management. There needs to be something on DPDK as well for a different paradigm. And as Venki keeps pointing out, there's lots of these different use cases, so you won't all use them. Platform diversity. I love being where I am because I'm at the low end, but I hate all these sexy features you're getting at the high end that I kind of use. And if you hear me talking to Intel, I've got one statement where I say, I refer the honourable gentleman to the statement I made last time, and that statement is, I've got to have it from the low-end Rangeley to the high-end Xeons. If you look at where Roger and I work, we have the high-end ASRs, which is an ASIC, and then there's a big Intel CPU babysitting it. Then we come down to start getting my platforms where I will use a Cavium in the data plane, great pipeline processor, and again with an Intel. And then the manager said, oh boy, we've got these Rangeleys, why don't we just take all that code and run it on a Rangeley? So we did. There's some interesting results. That's where the skeleton came from that Venki looked at and things like that. And then we got some more managers. That was sort of manager. Then the directors and VPs got in and they said, why don't we just compile it and put it in a VM? And the rest is history. We've had a lot.
Even the higher level, they say put it in a container.
Yeah, well, there are some containers I would consider. Look at Intel's Clear containers, because it's full virtualization, so you do get the protections and things like that, and they're pretty lightweight, but I'm not allowed to talk about technical things in this. So performance and then cost points. I've got to be able to run it on the low-end chips. I'm lucky because it's Rangeley, but we are going to get, as we get into IoT, some of the lower ends, which are typically ARMs and things like that. So again, it's got to scale that way. And these are embedded, dedicated devices that we have complete control over versus data center and open environments and things like that. So I would like all of that. Efficient model of packet movement. Why do I call it packet movement? Because at the beginning of this talk I said, well, we noticed that there were these two blocks and I could just DMA them. Well, we've got this service chaining, we've got these headers, we've got this deep packet inspection. So there's a bunch of metadata that goes along with this. So I not only have to move it from north-south, up and down the stack, which is the traditional way, but more and more when we get into NFV, you've got to move it east-west. And I think this is one area where all the people we've got lots of creative methods doing this. There's other creative methods, but I think the message has got to go back to the hardware vendors. This is a first-class citizen. We need this. Don't make it look like a NIC. VirtIO would probably be a good interface. A lot of people think, well, you know, the only interface we've got today is the NIC. Well, that network interface is so old. There must be better ways, and I think Virt.io has got some promise that we can start using it, because I don't want somebody negotiating course frames.
I see you and we have some common customers sometimes when we compete on some niche side, and I've seen cases where customers say they don't want VF, they don't want IGBF, they just want to see one head, which is Virt.io.
Mm-hmm.
So it would be nice someday to see some hardware that can send to the VMs something that look like a Virt.io device. Maybe we'll need some updates in the Virt.io specs, but I guess everyone will enjoy the same thing. So if we could, because IGB looks like IGB, then other vendors looks differently, and then we have specific behaviors for MTUs, for offloadings. If it's Virt.io, at least we have something which is unified. Of course, not good for hardware vendors, but we may find some added value. So I'm pretty sure we'll find it. But at least we have a way to start with the VMs, which has a value from day one, and that everyone can manage. Because if we go toward containers, Virt.io is going to show up in containers. And in containers, we'll have the VF too. So we'll have the same issues. We're in VM in the container, so we'll be back to the old days of today.
Oh, absolutely. I want more. I don't want just a path for data. I need inline crypto. I need MACsec type of level of crypto between these VMs. So, you know, I think it is a chance that we take a look at this. Everybody who's writing this and optimizing their code to do this, talk to Intel. They've done it before. Pre-Nehalem memory architecture, we all spent time optimizing. They blew all that code away by integrating the memory controller. So I believe Intel, ARM, and people like that, if we give them enough notice, they can do that. It's not a traditional path. We hit it full in the face with Rangeley that didn't have a level 3 cache. So, you know, you could get 10 gig up and down here, you could get minus 1.7 gig going this other way. So there were lots and lots of things, but, you know, if at an architectural level, I need to move packets, so that's metadata, and the actual blocks of data east-west in a secure manner. So I need the isolation, I need the IOMMU involved. So, you know, Stephen's comments about, hey, some of these IOMMUs don't work. Let's get them working, and let's make sure that we can do that in an efficient way. Any questions? Anyone disagree? Anyone asleep yet? Good. This is why I said daydreaming. And of course, I wanted hypervisor agnostic. I'd like to get rid of hypervisors altogether, but that's another set of issues.
I just want to clarify that claim, right? So do you guys are actually thinking of creating some kind of a standard like in the storage area, like NVMe or SATA, or ACP was the storage controller? The Intel's one, I forgot the name. AHCI, right? I mean, in the storage area, there is a single standard for, well, right now not a single one, but all the storage devices have, they're implementing either HACI, right, or right now NVMe, and that's it. They differentiate in different areas, but they have the single hardware interface, and there's only one driver with quite a lot of quirks, but still the one driver. So do you actually guys think about this one?
So at the top level, yes, but I'm from a networking company, and like you say, there are standards out there. They're domain experts in that area. I know IBM bought a company, I forget the name of the company, who are active in this, and I hope their code gets back and we all learn, because I use very little disk. The only place I start using disk is for content caching and things like that. And then it can be fairly slow, because my algorithm is, I take this PowerPoint slide, I run a hash on it. If the hash matches, I just send the hash. I've optimized, you know, it's a typical sort of way. So that storage can be fairly slow. Once I've set it, I just need to have it there if somebody doesn't recognize the hash in that. But there are people who are using DPDK to move data around, and that in the data center is going to be fairly important as well. And I think they will want the same things. It's a different set of metadata, it's a different packet, they will need it secure. So I think if you sort of go up to my level, things look the same. Now the devil's in the detail, which is why I don't want to go into the technical things, but sort of from an architectural level, this is a good thing to start looking at. Roles and responsibilities. People ask me, why isn't this first? Well, we've got to set a bunch of background, and if you look at that hourglass thing, the waist can be fairly narrow, so we put it at the traditional I/O. But what happens on IoT when we start talking about IP stacks and things like that? We're starting, even in the DPDK community, to get away from the drivers, and there's other functionality coming in. So how big is that waist? Is it fairly narrow and narrowly defined, and we let other people innovate elsewhere, or do we dig deeper? So I have no idea at the minute where those boundaries are, but we do need to identify what role we're playing in this network and what our responsibilities are. Because I think we should be starting to look at some of the common requirements that we have across the board. Again, clearly defined models and semantics. Functional characteristics, that's the package. Everybody in this room knows about that. If you break something functionally, you're normally out the door. You've got to do that. And I consider secure crypto and things like that as a functional. And then we've got the non-functional requirements. So when I go to deploy this, and I've got to run everything as root, that's a problem. You know, the further we go up the stack, the more you're giving access to things. I run as root. I give a lot of hackers a lot of chance to get in. So we've got to look what really needs to have those elevated privileges and what doesn't. People have found that, hey, it's a great place to attack a router. There's lots of different information and things like that going through these I/O levels. So let's just make sure that we have a set of people whose role is to look at the drivers and things that we check in with the view to security. Because it would be easy to check through. A lot of people haven't had the training in security, so that's a big issue. I would love the day when we stop talking about security, because security weaves its way through everything. If we stop talking about it, that problem's solved. Unfortunately, we still talk about it. We still talk about it as a separate thing, but we've got to start looking at it as an internal thing. Performance. Now, who in here knows what performance is? Because I'm not talking about the cycle counting that you guys are all into, sorry. I haven't got an Alice and Bob at Cisco, but I've got a John, a Trevor, and a Keith. John is having these battles with Venki about who can get a packet through in the least number of cycles. And he comes down and John goes, hey, I'm beating Venki, and the management are patting him on the back. Well done, John, that's great. So there's one view of performance. Keith and Trevor have to deploy 900 VMs with 5 things in a chain, so they're looking at system resources. And they hate John because he wants the whole machine. So you start looking, and Cache QoS, I've mentioned it a number of times. Keith and Trevor think this is great. They can carve up defined cache memory bandwidth for each VM. So if you've got noisy neighbors, your VM still gets some traffic through it. They love it. John loves it for another reason. He said, I can give all this cache to the data plane and the control plane. Well, you know, they can make up their own time. So again, you've got a different set of perspective. In fact, the only thing I can see the two groups agree on is they both hate NUMA. It causes deployment problems, it causes performance problems. We need to start extending interfaces and not necessarily changing them. So there's lots of papers out there on the open-close principle and things like that and how you can do this. This is, the Red Hat people brought this up a lot with all the ABI stuff that was done in 2.0. It's going to get even more important. We've gone through the can we do this stuff. Yes, we can. Now we've got to start planning for success. So there's going to be a lot more constraints on things. People can't keep changing their applications all the time. So we've got to look at how we extend without actually changing. And I think you can do that. Management and instrumentation is going to change a heck of a lot. As I said earlier, we've got these controllers out there. They're making money. Do we have a consistent set of statistics so that they can start this sort of closed loop? A manager measures something, he looks at how he can change it, he redeploys, and you go around in that circle. Well, that circle has now been extended outside of the network manager or the system administrator up to some controller, because people are going to start paying money for this. So we talked about the NIC. I don't want that stuff going up there. So it's good to export it to a certain level, but then we've got to do what the Ericsson guys have done and said, fast, medium, slow. I can deal with that semantically up at a high level, and then what that maps to later is a quality of implementation sort of issue, but we've got to do some mapping. There are ontology issues that you've got another set of users who have no idea what a VF is. They just want to have their application run faster. So that whole thing has got to change. And then you've got all the latency and the distributed management we're going to have, because there's a dirty rumor that networks aren't reliable. So don't rely on it being there. And normally they're least available when you need them most. When you're trying to debug that network problem, the network's down at that point. So you can't always get to it. Configuration. We saw some good stuff again from Ericsson where they're trying to abstract this out. But how do we get the number of virtual functions to somebody who is going to make a deployment decision? We've got to have that capabilities exchange. We've got to be able to have some abstract entity go in and configure it, whether it's an open daylight controller, any of these controllers that are coming out, you've got to be able to get them to that stuff. And then deployment and tuning, again, I think we've got to do a better job. And this isn't just DPDK, this is this abstraction layer I'm sort of talking about. Finally, I want portable code across systems. I didn't want to put RTP underscore or ODP underscore or XYZ underscore. We need a code base that we can take from platform to platform to platform, compile it, and it automatically works. And we need those performance guarantees, because the bottom line, once everybody's got the functionality, your quality of implementation is normally judged on your performance. Good documentation. Just backing up what Thomas has said, we're responsible for our own stuff. We've got to document it. We've got to realize that the users of the documentation aren't necessarily as technical as the people in the room. So we've got to put that up to a different level. It's definitely needed. We've got to have a test framework. And I believe that test framework has got to include things like acceptance criteria. As we go through and DPDK goes and goes and goes, we can't have features coming in and destroying performance. So there'll be performance and functionality tests that I believe should be run, so that when we get DPDK or Red Hat get DPDK and they're going to deploy it, they don't need to spend 6 months testing. Now this is a whole different philosophy, because now the hardware vendors maybe have to take some responsibility where they front end a mail system and then automatically submit a batch job, do some things, send some results back. So again, the roles and responsibilities of the developers and the companies like Cisco who put in the Cisco NICs may have to change, but we've got to do that, otherwise everybody else will have to go do that testing, and the number of man hours doing basic testing, it will just add up and that. So people, if that adds up too much, what my management team are going to say, well, don't go to the next release. So again, you're going to get things like we have with the kernel, where to move forward, it's much too hard. We've got to try and alleviate that. I think there are some ways to do it, but you know, there's probably a lot more people in this room who know a lot better than I do. Questions? 10 minutes before lunch, so somebody tell me I'm just full of it, and then we can debate it. Does anybody think that we don't need to grow in this direction? Anybody think we shouldn't have more hardware architectures?
Yeah, hey, one question here.
Well,
So I understand your perspective, like you would like every vendor to kind of implement the same APIs, and you, from your perspective, just be able to kind of integrate this seamlessly, just transition from one implementation to the other, and get performance guarantees and without breaking your code. But how do you see this from, if you put yourself in the vendor's shoes, like, do you think this would actually be appealing to them? I mean, if they all look alike, then maybe, and they all implement the same things in the same way, maybe some of them will go out of business and only one guy will be left standing.
I have great confidence in the hardware vendors that we use, and the biggest problem I have is seeing all this innovation, because there's some really neat stuff coming out that I can't necessarily use. So we've got to have an architectural baseline at some point. I think you know, the hardware vendors will innovate. It just comes out, do I need to support a bunch of stovepipes for boutique IOs for everybody, or can we bring this up and start saying, hey, look, you know, if you've got a strong core and you don't have this implemented in hardware, or do it in software. I'm not dictating where it should happen, it's just I need this quality of performance. If you could do it in software, that's great. And I think this is really, really powerful because it does allow us as a software community to start driving some of the hardware vendors to get to that architectural baseline. Now, they'll always want to compete, and there's lots of factors on how they compete, but I think, you know, as I said at the beginning, we're Caltrans. At the bottom of the day, we're Sherpas. We're carrying those bits. The hardware vendors, they need to be relevant to a number of spaces, and these spaces will be different. So I think hardware vendors will be able to innovate and will still carry on. We've had this issue for a long time at Cisco. We've been IO bound, and we've come up with, the hardware vendors have never failed us in how they can innovate and move forward. But nobody's tried this common thing. In fact, we tried everything common except common sense. So,
Do you see guys like Cisco and like guys working at your level to actually start publishing some of these requirements, some of this API, like, hey guys, I need you to implement this API for us.
So,
and hey, whatever vendors, whatever suppliers, please align to this API for I/O or for whatever function.
So Cisco actually did that and sent it to all the vendors and said, hey, here's what we want from crypto. Go away, run it, give back our stuff. I know Intel looked at it and went, ooh. But we did, if you look at the CDAL interface that is sort of an ODP, we tried with that interface. And I know Intel and Cisco and some of the ARM vendors have met recently to talk about those sort of things. So I think, you know, we have done that. We haven't done enough, but I don't think we've necessarily had the focus in the right place.
Any intention to actually open source those specs or those requirements?
I don't know. I hope that there's not many more meetings, and then we can form some group and start pushing them out. This is a big area. There's lots of change that needs to happen, and I think we can move forward. Hey, why are you picking on me? Because I said about my slides just and picked on you.